This is not a UFO, and it is not AI. This is a real cloud, a supercell thunderstorm, and it may be the most organized form of atmospheric violence on Earth. It looks painted, hand-sculpted, like Mother Nature lowered her mothership out of the sky. But here's the wild part. This structure is built by nothing more than the invisible wind. Supercells are the storms that can produce giant hail, destructive winds, and some of the strongest tornadoes on Earth. Stick around, because by the end of this video, you'll know the magic recipe for identifying these atmospheric monsters with just your eyes, including the part of the storm that can become the birthplace of a tornado. If you love learning about the weather without the hype, subscribe to Untamed Skies, where science meets humanity. To understand thunderstorms, picture a pot of boiling water. When heat is added from below, bubbles rise, the fluid overturns, and energy is transferred upward. This process is called convection, and the atmosphere does something similar. As the sun heats the ground during the day, the warm, moist air near the ground becomes buoyant and rises. As it rises, it cools. As it cools, water vapor condenses into cloud droplets. The release of heat that comes with the condensation helps the air rise even more, building a tower of cloud higher and higher into the sky. This rising air current is the updraft, and this whole process is called convection, which is why meteorologists, including those you see on TV, often use convection as a fancy word for thunderstorms. At first, a forming thunderstorm is almost all updraft, warm, moist inflow feeding a growing cumulus tower. But then, rain and hail form inside the cloud. That precipitation is heavy, so it drags the air downward. Evaporation cools the air, makes it denser, and a downdraft forms. In a normal thunderstorm with little or no vertical wind shear, meaning the wind stays about the same as you go up in the atmosphere, the downdraft falls right back through the updraft. Cool outflow spreads across the ground, cutting off the warm inflow, and the storm basically chokes itself off. That's why many ordinary summer thunderstorms flare up, rain hard, and die in less than an hour. Wind shear is what turns a thunderstorm from just a rain machine into a rotating engine that can last for many hours and spit out tornadoes. Vertical wind shear means the wind changes speed, direction, or both with height. Instead of the storm standing straight up, stronger winds aloft tilt the storm. And that tilt is crucial because it separates the updraft from the downdraft. The storm's cold outflow is pushed away from the warm inflow. The updraft keeps breathing, so the storm keeps eating, and it lasts longer than the storm that formed without any wind shear. This is how you get severe thunderstorms. Wind shear is the secret sauce. But vertical wind shear does one more thing. It creates horizontal vorticity, invisible rolling tubes of air like a paper towel roll spinning sideways. When a strong updraft grabs that rotating air, it tilts part of that spin upward. Now the updraft itself begins to rotate. That rotating updraft is the mesocyclone, the heart of a supercell thunderstorm. In many northern hemisphere supercell setups, the counterclockwise or cyclonic circulation is favored because of how the updraft interacts with the wind profile and dynamic pressure perturbations. The details involve a bunch of calculus, but one thing is important. This is not because of the Coriolis force. Supercells are too small and evolve too quickly for Earth's rotation to be the main reason they spin. Check out this video here for more on the Coriolis force. There are rare clockwise left-moving supercells, but the classic tornado-producing supercell is usually built around a persistent cyclonic mesocyclone. And things in nature, once they start spinning, often last longer, so unlike your typical summer thunderstorm, supercells can live for hours, not minutes. A supercell may look chaotic, but it is actually one of the most organized storms on Earth. The warm inflow feeds the storm from the surface. The mesocyclone is the rotating core. The overshooting top is the updraft punching above the anvil, which is the top of the cloud that pancakes outward. The anvil spreads downwind, high in the atmosphere. Mammatus clouds that look like pouches can hang beneath it. The flanking line is a chain of smaller cumulus towers feeding the storm. The wall cloud is a lowered cloud base beneath the mesocyclone, and if conditions line up, a tornado can form below that. On this real time lapse, watch the mesocyclone here. The forward flank downdraft is the rain and hail area ahead of the storm. The rear flank downdraft wraps around the backside, and that blue sky in the back shows that supercells are loners, storms that prefer to hog all that warm, moist inflow air to itself. On radar, that same structure can show up as a hook-like shape. Rain blowing around the rotating mesocyclone is what creates the hook, with inflow feeding into the notch, the forward flank downdraft in the main precipitation shield, and the rear flank downdraft curling around the circulation. In this actual radar animation near the Dallas-Fort Worth area, you can see several supercells forming and moving to the northeast, each with its own mesocyclone. But as impressive as the radar signature is, it still doesn't do a supercell justice compared to actually seeing one in person. From far away, a supercell looks a lot like a large version of a normal thunderstorm, a cumulonimbus or anvil cloud. But when you get closer and are near the base of the cloud, you see the true telltale sign, the mesocyclone. This is the heart of the supercell. When you stand in front of one, like I have many times while doing tornado research out in the field, the storm feels alive. An imposing mothership hanging over your head, the striated cloud structure carved by the wind, like Mother Nature making pottery out of thin air. A supercell is where art meets science, where beauty is destructive, where awe begets fear. Nothing else on Earth comes close to revealing this duality of permanence and impermanence right in front of your eyes. No satellites and no radar necessary. I have goosebumps just thinking about this. Inside the base of the mesocyclone, a lowering can form where cloud motions tighten and where the pressure is even lower. This is the wall cloud, and it can be a precursor to a tornado, though not every wall cloud produces one. So when it comes to supercells, there is a method to the madness of atmospheric violence. A supercell is a structured engine where every part serves a purpose, and knowing that structure could mean the difference between confusion and action when seconds count. In a future video, we'll break down the sequence of events that you'd experience if you're ever caught in the path of a supercell, and what it means to be in the calm before the storm. Drop a comment with what you want to learn next about supercells, and subscribe to Untamed Skies for more weather explained without the hype. Keep looking up.